Hello everyone, my name is Dr. K.C.H. Apparao, working as an associate professor in Mechanical Engineering Department. Okay, today I would like to explain about the fuel injection systems, mainly in SI engines. In last class, we discussed the combustion process in SI engine and combustion process in C engine. Now we'll see injection systems, fuel injection systems in SI engine and C engine. So, as for the traditional system, you know that fuel injection system only used for C engines. But nowadays, fuel injection systems also used for the SI engines. Before going to discuss about our class, our current topic, we'll see the course outcome of this topic or this unit. So, at the end of the course, students should be able to classify the fuel injection and ignition systems, fuel injection systems and ignition systems to pretend the application of combustion chamber. So combustion chamber types such as T head and overhead. Now we'll see fuel injection system. Okay, as for the traditional system, you know that for spark ignition engines, for the spark ignition engines, so this is the basic model. Inlet port, exhaust port. So this one is the top dead center TDC piston. This one is the bottom dead center PDC. So in inlet port, we will see the inlet valves. If it is four-stroke engines, inlet valve. So this one is the inlet manifold. Inlet manifold. And so this one is the outlet manifold. So in outlet manifold, we will see exhaust valve. Exhaust valve. So this is the system. So in the previous systems, we will use this spark plug for the ignition systems. We are not discussing about the ignition system. We are discussing about here injection system. Injection system, it means taking of the fuel or injecting of the fuel into the cylinder. So as for the system, traditional system, there is a carburetor to supply the air-fuel mixture into the cylinder through inlet manifold. You know this one. This inlet manifold is connected with the carburetor. So through carburetor helps to provide the air-fuel mixture charge. Okay. So it takes air and through orifice and it provides the proper mixing of air and fuel, petrol, and the air fuel mixture is supplied to inlet manifold. So through inlet manifold that comes into engine cylinder. We know this system, but nowadays injection fuel injection systems are using in spark ignition engines. So because there are some limitations for the carburetors, because the carburetor, so the just like airflow is less because of the air which is taken through orifice. So the airflow is less. So a carburetor just like doesn't give the proper mixing of air fuel mixture. So it means optimized mixing or maximized mixing. So it means required mixing of air fuel is not provided by carburetors. That is the one of the drawback of carburetor. So next, carburetor supplies sometimes uh, maximum amount of air fuel into the cylinder over air fuel mixture into the cylinder. So it doesn't measure the required quantity to supply to the cylinder, but it supplies air fuel mixture in over air fuel mixture. So due to the over air fuel mixture, so some wastage of air fuel will occur that leads to efficiency and just like efficiency of the engine also decreases. So there are few more drawbacks also there for the carburetor. Carburetor in the just like based upon the climatic conditions, carburetors doesn't work functionally because it leads to some starting problem, starting of the uh, engine problem, because in the starting, just the carburetor should provide the over air fuel mixture. So the carburetor fails to provide according to need. So according to need of charge, volume of the charge. So based upon these drawbacks, nowadays fuel injection systems are replaced with the carburetor mainly. So because the fuel injection systems have better um, features compared to carburetor. So fuel injection system for spark ignition engines are designed to precisely deliver fuel. So required amount of fuel to deliver fuel into the engine's intake manifold or directly into the combustion chamber also. Two methods. Through inlet manifold, we can supply the air fuel mixture or charge into the cylinder. Otherwise, we can directly inject the air fuel mixture into the cylinder. So, uh, by using this air fuel injection system, we can supply or we can uh, inject the air fuel mixture into the cylinder. So, this is the main advantages. But carburetor only through it supplies the air fuel mixture through inlet manifold. Okay. So that ensures because of air fuel system or fuel injection system for SI engine are designed to precisely deliver fuel into engine's intake manifold or directly into the combustion chamber. So because that ensures efficient combustion, effective combustion and efficient combustion. Also improve fuel economy also because it provides the measured fuel, the required amount of the fuel. So not extra, not less. So optimized amount of fuel is supplied by fuel injection system. Okay. So fuel economy also increase. Next to reduced emissions also because over amount of fuel supply that leads to unburned fluid particles, unburned fuel, fuel particles. These are occupied into these cylinders. Okay, so if you supply the required amount of optimized amount of this air fuel charge, then that leads to proper efficient combustion, improved fuel economy, and reduced emissions also. So these systems have largely replaced the carburetors in modern SIMs due to the better control over the fuel delivery. So, okay. So this is the main advantage of fuel injection systems in spark ignition engines also compared to carburetors. So according to traditional system, carburetor is used to provide air fuel ratio, air fuel mixture into the SI engine. Nowadays, that place is replaced by fuel injection systems. Okay, so this one is the transition of fuel supply. Previously, carburetors were used. Nowadays, this place was replaced by port injection. So port injection means we'll see the air fuel mixture is directly supplies near the inlet valve, near the inlet valve, not in throat. We'll see what is port injection, types of the port injection also. So otherwise, or manifold injection also. Manifold injection is nothing but the air charge is injected into the fuel is injected into the throttle, or a manifold of the inlet valve. So through this manifold, air fuel mixture comes into the cylinder. One more method is the direct injection. Direct injection means, so at the end of the compression stroke, the air fuel mixture is injected into the cylinder directly. Directly, this one is injected into the cylinder. So this is the carburetor system. Sorry. So carburetor supplies the air fuel mixture into the inlet manifold. So this one is the just like a injection. Port injection means, so the air fuel mixture is injected at very near to inlet valve opening. So the air fuel mixture is taken into the cylinder. So last one is the direct injection. Direct injection means the air fuel mixture is injected into the directly cylinder. So at the end of the compression for the combustion process. So this one is the transition of fuel supply systems nowadays. Carburetor is replaced by port injection. These are compared to port, direct injections also very advanced, very useful ways to inject the fuels into the cylinder. Now see, so in 1970 to 1980s, carburetors were used. Next to the place was replaced by port injections. Now this one is replaced by direct injection systems. Now we'll see what are the main advantages of the fuel injection systems for SA engines compared to carburetors. Okay. We'll see few points regarding this one. Fuel injection system offers several advantages over the carburetors, especially modern modern internal combustion engines. Okay. So we'll see some key benefits. What are the important benefits? The first one is the better fuel efficiency. Better fuel efficiency because carburetor doesn't measure the air fuel mixture. It supplies uh, continuously. Okay. So based upon the requirement or based upon the conditions, it doesn't change the volume of air fuel mixture to supply into the cylinder. Okay. So but based upon the sensor system, fuel injection systems works. So based upon this requirement, it increase the volume of air fuel mixture and reduce the volume of the air fuel mixture, uh, which passes into the cylinder, or which which is injected into the cylinder. Okay, better fuel efficiency. So fuel injection provides precise control over the air fuel mixture. Okay, so reducing fuel wastage, improving the mileages. Precise control. In starting, air fuel mixture required more air fuel mixture. So based upon the system, based upon the climatic conditions also, it provides precise or optimized required amount of air fuel mixture. So that is the main advantages. Next, improved power and performance also. Okay, so optimized fuel delivery supplied by air fuel injection enhances engine performance. Okay. So required, uh, it's because fuel injection system provides the optimized required amount of air fuel mixture. So combustion takes place effectively, automatically engine performance will be increased. So it offering smooth acceleration also, better acceleration, and better throttle response also will get. Next, to lower emissions, because there is no over rate of air fuel mixture, less rate of air fuel mixture. So because this air fuel injection system provides optimized required amount of air fuel mixture, because it measures the air fuel mixture and provides the air fuel mixture. So fuel injectors ensures complete combustion. Okay, so if the over air fuel mixture is there, automatically unburned fluid particles will be just placed into the cylinder. Okay, so if you provide the optimized level, sufficient amount of air fuel mixture, so we will see the complete combustion process and reducing the unburned fuel and lowering the harmful emission also. Harmful emission. Next, better cold start also by the carburetor. So unlike the carburetor, because of the carburetor, we will see just like we struggle with within the in the cold weather. Okay, unable to start. So we have to give more strokes, uh, more kicks to start the vehicles. Okay, so this problem was rectified by the just like fuel injection system. Okay, so unlike carburetors which struggle in cold weather, fuel injection adjusts fuel supply based upon the atmospheric condition, based upon the temperature. So that ensuring the smooth start. Okay, so if the condition is the cold conditions, it supplies more air fuel mixture, automatically ignition takes place. Okay, so by fuel injection system, so we can get these smooth starts also. So next, enhanced engine long life, like longevity. So proper fuel automation. Automation means big particles are converted into small particles. So these small particles are enveloped with the air. It means proper air fuel mixing. So homogeneous mixing will occurs that produces the uh, that leads to effective combustion process. Okay, so proper fuel automation reduces the carbon deposits, leading to less engine wear and tear. So that automatically leads to extended life. So next, to altitude compensation also. Fuel injection automatically adjusts the charge in air pressure and maintaining efficiency at different altitudes also according to the system conditions. So based upon the sensor signals, so it just like it supplies the air fuel mixture. Next, reduced maintenance, because unlike carburetors which requires frequent cleaning and tuning, requires the carburetor, we know that one. So fuel injection system need less maintenance, no need of cleaning and tuning frequently. Next, to more precise fuel distribution. This is very important. So because fuel injectors distribute fuel more evenly among the cylinders and reducing the engine knocking automatically, it improves the efficiency also. So many advantages are there by fuel injection system. So nowadays the fuel injection system is replaced with the carburetors places. Okay. So we'll see the types of petrol injection systems. Petrol injection system basically two types. One is indirect injection system and direct injection system. Indirect means the air fuel mixture is injected into just inlet manifold. Inlet manifold. You know this one. This is the inlet manifold. Inlet manifold. So air fuel mixture is injected into inlet manifold. So through inlet manifold, air fuel mixture comes into the cylinder. Okay. So direct means the air fuel mixture is directly injected into the cylinder. So that is the two methods or two ways are there. So indirect injection system or manifold injection, we can simply call this. And gasoline direct injection. Direct means injecting of air fuel mixture into the cylinder. So it means in the combustion chamber. So directly. Next, indirect injection systems also two types. One is the single point injection system. Next one is the multi-point fuel injection system. Okay. So single point also two types: throttle injection and port injection system. We'll see what is throttle injection and another one is port injection system. What are the differences between these two injection systems also? Multi-point fuel injection system also two types, same throttle injection and port injection. We'll see what is throttle injection system and port injection system. So, same we can classify based upon these points also, based upon the ignition mode. This is two types: direct injection, indirect injection. Based upon the port injection, two types: single and multiple. Okay, so based upon the throttle and single and multi-point also. Okay. So type of activation also, to activate this one, some electrically control units are there to control the fuel injection systems. We'll see later. The first one, we know that there are two types of injection system. One is a direct injection system, another one is the indirect injection system. So this one is the just like indirect injection system. Indirect injection system. It means you know that this is the just like manifold of inlet. So air fuel mixture is injected into the throttle of manifold or inlet to manifold. Okay. So through this inlet manifold, air fuel mixture is taken into the combustion chamber. So this is the indirect injection system of the fuels. So this is the direct injection system. So in the direct injection system, the air fuel mixture is injected into the directly combustion chamber, directly into the cylinder. Okay, so this one is the indirect, this one is the direct. We'll see single point injection system. We will see what is the single point injection system, what is the multi-point injection systems also. Okay, the earliest and the simplest type of injection system, this is the first injection system, that is the single point, simply replaced the carburetor with one or two fuel nozzles in the throttle body. So is the throat of engine's air intake manifold. Air intake manifold. You see the diagram also. Single point injection system that measures the fuel. Okay. So it means it measures the required amount of the air fuel mixture. So then carburetor. Okay. And is less expensive and easier to service. This is the advantage of single point uh, injection system compared to carburetor. So the single point injection systems are two types. One is the throttle injection system. Next one is the port injection system. So we'll see. First one is the throttle injection system. Uh, so this one is the indirect injection system. You know this one. Indirect injection system is classified into single point and multi-point. Okay. The single point injection system also two types: throttle and port types. We'll see. The single point injection system also nothing but throttle injection system, in which the fuel is injected at one place and one place in the throttle body. Okay. So throttle body means inlet to manifold body. So in that inlet manifold, so the fuel is injected like this one. For the two cylinders, the fuel is injected here. So through this inlet valves, inlet to manifolds, the fuel is just passes into the cylinder, okay, like this one. So this is the just indirect manifold system or indirect injection system. Uh, Here air fuel mixture supplies to different cylinders. So air fuel mixture is injected here. Next, the air fuel mixture is distributed. So some portion go to one cylinder, some portion goes to another cylinder. So these are the exhaust gases. So this process is nothing but throttle injection system. Now we'll see. So this one is the throttle injection system diagram. You can see like this. Next one is the port injection system. Port injection system is, so there is a small difference between the throttle injection system and port injection system. This is the throttle injection system. This one is the port injection system. In the port injection system, the air fuel mixture is injected very near to inlet valve, very near to inlet valve, like this one. Okay. The air fuel mixture is injected directly very near to inlet valve. So in case of port injection, also called as multi-point fuel injections. So the port injection we can use it in just like a single point and a multi-point also, no problem. So air shucks through throttle body and fuel is, so here air is taken through throttle body. Only fuel is injected very near to uh, inlet inlet opening. Okay, so injected fuel is injected near inlet valve. So very of every cylinder. Okay, so it means through throttle or through inlet manifold, air is taken. Okay, so but every cylinder very at that it means very near of inlet valve. So the fuel is injected. Only fuel is, the petrol is injected to the uh, very near to inlet valve. So this is the port injections. Here we can see the diagram. The previous one, the fuel is injected here for the throttle valve, but in port injection system, so at every point, for every cylinder, the only fuel is injected very near to inlet valve. Okay, remaining air is taken through manifolds, inlet manifolds. So each cylinder have each fuel injectors. This is called port injection systems. So next, multi-point fuel injection system. Multi-point fuel injection system is widely used in petrol engines in the place of carburetors nowadays. The purpose of multi-point fuel injection system is it supplies the proper air fuel mixture ratio to each cylinder of the engine. Okay. So multi-point means for each cylinder it provides the proper air fuel mixture, means proper charge or required amount of the charge will be supplied to each cylinder. Okay, first fuel tank, the air charge is taken through pumps. So that is high pressure petrol. So due to pressure and supplies to distributor through distributors to fuel injectors. Okay, high pressure charge, so supplied to fuel injectors through fuel injectors, just like it's supplied to cylinders. Okay. This cylinder either by uh, fuel system or throttle system also. So nowadays, multi-point fuel injection systems uh, are using. So these are controlled by some device that is called electronic control module. So this electronic control module, so it operates the this multi-point fuel injection system. So this ECM receives the signals from different sensors. So sensors gives the condition of atmosphere, condition of the just like uh, engine also, just like we'll see different what are the different types of the sensors. So these sensors gives the different signals. Based upon those signals, so ECM controls the multi-point fuel injection system. So that supplies the optimized amount of fuel as per the requirement, without wastage of air fuel mixture. So based upon the also it provides the proper mixing also. So ECM receives the signals and sent to solenoid operated fuel injectors to, for the what purpose, to meter the means to uh, to supply the optimized amount of air fuel mixture, and inject right amount of fuel at the right time. So that is the main advantage of uh, multi-point fuel injection system, which is operating by ECM. Okay. So these are the different types of sensors in multi-point fuel injection system. So inlet manifold pressure sensors are there. You know that based upon the inlet manifold pressure, so the fuel pressure uh, is adjusted. Next, airflow sensors. Okay. Next to engine speed sensors, throttle position sensors, coolant temperature sensors also, because the engine should maintain certain temperature for the proper compression pressure, proper combustion. Okay. Next to inlet air temperature sensor also there, knock sensoring also there. Okay. So overheat leads to some knocking position, knocking problem. Next, exhaust gas sensors also. Okay, so these sensors gives the signals to ECM. ECM controls the supply of air fuel by multi-point fuel injection system to engine for the proper running or proper combustion. Okay, so we'll see. So next one is the direct injection system. Direct injection system means we know that one, the fuel is directly injected into the cylinder. So sometimes only fuel will be injected. Sometimes air fuel mixture also will be injected. Okay. So these systems inject the fuel directly into the combustion chamber, either during the in- intake stroke or during the compression stroke. Okay. So these are two basic type of direct injection systems. Either injection of gasoline alone. Gasoline alone means injection of fuel only, or dual. Dual means so air fuel mixture also. Okay. Injection of fuel alone is usually done during the compression stroke. You know this one, and is somewhat very similar to C engines. So you know the process of C engines. So because of the very short time available for the evaporation and mixing with air, so very fine droplets of fuel are required. You know that it means so proper atomization should be needed. So our high turbulence and bulk mass motion within the combustion chamber. For these purposes, it supplies the air fuel mixture. So this is the advantage of direct injection system. Okay. Direct injection system. So injector. So injector pressure must be higher than the required for the port injection system. So these are the some comparisons of direct injection system and the port injection system. So this is because of higher pressure into which the fuel is being injected, and because of the requirement for finer droplets of the fuel. So here you can see. So these are the advantages of the direct injection system. So nowadays the fuel injection systems using in two-wheelers mainly FZ, S. Okay, so it uses advanced sensors. You know that fuel injection systems. Uh, so run by ECM. ECM takes this feed signals from the sensors. So based upon the sensor signals, it supplies the fuel, air fuel mixture. So it uses advanced sensors and actuate actuators to calculate and deliver the optimized amount of fuel. Optimized amount means the required amount of the fuel based upon the climatic conditions, based upon the just like sensor signals. Okay. Next, more responsive, leading to quick initial pickup and delivering smooth passaging. Okay. So we can see. So it achieves 14% improvement in fuel economy, because we know that we already discussed the advantages of fuel injection system. So its intake and exhaust valve layout is designed to best match the hemispherical combustion chambers. So in combustion, so with the optimized intake and exhaust port shapes, so this design increases the combustion speed and helps achieve the excellent combustion efficiency. So because of optimized design of the combustion chamber and optimized supply the fuel mixture, so efficiency of the engine, performance of the engine is increasing rapidly. Okay, the new engine further improves the fuel efficiency, and just like a feeling of acceleration while retaining the excellent performance. So the qualities are using the current FJet engines. Okay, so these are the main advantages of uses of fuel injection system nowadays in the two-wheelers compared to carburetors. Okay. So almost the fuel injection system nowadays replaced the uh, position of carburetors because this system has high advantages compared to carburetors. So these are the references for more information. You can go through these textbooks. Thank you for listening this class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.